In this video, we're going to show the disassembly and modular construction of the Maivin AI Vision Starter Kit. The Maivin Kit is a complete solution for developing high-performance custom vision sensors with an integrated NPU and machine learning. It is constructed with production-grade hardware and software components from Ozone, Toradex, and Vision Components for rapid prototyping and field testing, as well as production deployment. Disassembly of the kit requires a few simple hand tools. Here, a small slotted screwdriver is used for removing the power connection from the rear terminal block. Next, a 2mm hex screwdriver will be used to unscrew the bottom of the enclosure from the assembly. The other tools that are required are a 1.5mm hex screwdriver, a small Phillips screwdriver, and a small pair of tweezers for disassembly of the interconnecting rivet cables. After the four mounting screws are removed, the bottom of the enclosure may be lifted off, revealing the internal hardware components. Once the bottom is removed, you can see a vision sensor module on the left, a main baseboard module in the center, and an interconnection rear terminal module on the right. The back of the Maivin baseboard connector has a CSI MIPI interface connector for connecting to the sensor modules, as well as an LED driver, and an optional secondary CSI connector for adding an additional sensor. There's an SD card socket for expanding the internal flash, a SIM card connector for the optional LTE modem, some headers for debug serial ports, some switches for recovery and reset, a header for some optional I/O, as well as a connector for real-time clock battery backup. There's a connector for interconnect to the rear terminal module, as well as a secondary connector for an optional power over Ethernet module that can be added to the board. There's a USB on-the-go connector for software recovery, the M.2 connector for LTE modems, a JTAG connector for software debug. The next step in the disassembly process is removing the connector from the image sensor module from the baseboard. There are a number of slots in the enclosure to accommodate different sensor modules for vision components. Here, a pair of tweezers are used to unlock the CSI image sensor connector, and the cable can be gently removed. The embedded camera module used on the Maivin platform consists of a MIPI image sensor module, a lens holder, and a mounting plate. The lens or sensor module can be customized for your application. An optional cover plate can go in front of the camera module, or this can be replaced with a LED flashboard. The next step in the disassembly process is undoing the connector for the flex cable to the rear terminal module. Once the connector is undone, the flex assembly can be gently removed. The standard configuration for the rear terminal module consists of an RS-45 connector for gigabit Ethernet, as well as a terminal block with connections for input power supply, RS-45 serial connection, a CAN bus connection, and GPIO, which can be configured as inputs or outputs for various functions like camera synchronization or trigger outputs. The four 1.5mm, 5mm hex screws are removed from the baseboard, which are used to mount it to the top of the Maivin enclosure. Once the screws are removed, the baseboard can be removed from the top of the enclosure to reveal the embedded SAW module and heatsink assembly. Next, a small Phillips screwdriver is used to remove the four mounting screws which hold the heatsink assembly on top of the Verdon 8M Plus SAW module. With the screws removed, the heatsink assembly can be gently twisted and lifted off the embedded SAW module. The Verdon SAW module contains the IMX8 M Plus CPU, an 802.11ac Wi-Fi module with two antenna connections, 16 GB of internal flash, and 4 GB low-power DDR4 memory. The two mounting clips are spread out to disengage the SAW module from the socket, and the SAW module can then be gently removed. This concludes the disassembly of the Maivin AI Vision Kit. In summary, the Vision Kit consists of a modular ozone baseboard, a rear terminal board which can easily be customized for your application, a number of production-grade camera modules which can be selected for your use case, an enclosure which is used to house the different hardware components for easy benchtop or field testing, and a high-performance embedded SAW module which can be selected with different build options to optimize the price and performance for your production design. These hardware components are fully integrated with a production-grade BSP and DeepView Vision Middleware, as well as models and applications to de-risk your development and speed your design into production.